Forecasting can be used for multiple things in supply chain. For example, we can forecast demand for products or services, purchase prices, replenishment quantities, and delivery times. We can also classify forecasting for different purposes. For example, forecasting can be done for strategic planning. This is long-range planning, usually 3+ years. For example, when you perform forecasting to decide capacity expansion, new facilities, and so forth. It can be also used for finance and accounting, such as budget and cost controls, for marketing, and more specifically production and operations. There are some key issues related to forecasting. The first one is a forecast is going to be as good as the information you provided for the forecast itself. More specifically, the past data you use in these calculations. The second one you need to be aware of is that what we are using is the past data, and we are assuming the past is going to be some kind of an indicator of future. This may or may not be always true. So when you do forecasting, you need to be aware of that fact. So given that we know there are some issues related to forecasting, what makes a good forecast? First one, it needs to be timely. That means basically when you need the forecast, it should be available to you. If it is available later than you need it, then it is not really a good forecast. The second one is that it should be as accurate as possible. When we talk about accuracy, you need to think about two things. The first one is the accuracy of predicting the underlying pattern. So if, let's say, there is a seasonality, does this forecasting method capture that seasonality? The second one is accuracy of the changes. So that is basically how fast forecasting procedures can respond to the basic changes in the demand pattern. For example, you may be in a seasonality pattern and suddenly there is a increase in the overall demand as well. Would your forecasting pick up that one or not? The third point is that it should be reliable. Basically, when you have a forecast, you need to be able to rely or trust that result and make some plans accordingly. If you cannot trust the forecast result, then it's not really a good forecast. The forecast should also be in meaningful units, which means basically if you are doing, let's say, a forecasting for production planning, a sales revenue forecast will not make much sense. In that case, you need production quantities forecast or the demand forecast actually to basically meet that expected demand. The forecast should be in writing. This basically makes sure that there is a procedure for it rather than some people coming up with some random numbers. And finally, hopefully this method is easy to use and understand in most cases. Now, there are some forecasting methods out there, especially quantitative forecasting techniques. They are very rigorous, and explaining them may take a lot of time, and it may not be easy to understand, but as long as they are accurate in terms of what they are doing, we will still accept them. There are many forecasting techniques out there, and the companies can use basically one or many of them. But the forecasting decision is usually depends on the purpose of the forecast, right? So you need to decide what is this purpose, and based on that purpose, you need to also decide what is the importance of improving the forecasting accuracy. For example, when you need gross sales estimate, improving forecasting accuracy may not be that important compared to a situation where you are using forecasts for the weekly production planning. In the weekly production planning, if you forecast more than the demand, you will end up with a lot of inventories. And if you under forecast, in that case, you will have some backlogs or lost sales. So improving forecast accuracy in the second scenario might be more important compared to a gross sales number in a year. The second one is understanding dynamics of business and customer. Is your business more impacted by the economics trends, or the products you have or your customers' choices. So depending on that, you may consider different forecasting techniques. Once you decide first two, then the next step is gathering data and identifying patterns. Usually this is the most difficult part, because once you know what type of data you need, some of those data may or may not be available to you, so you need to go search for it, especially for economic data or economic forecast for the future. Then we go through certain processes and determine the best forecasting method. Next step is basically preparing the forecast, and this step cannot end at one point. It needs to be monitored and updated. What we say is that once you choose the best forecasting technique, depending on the product type, product life cycle, and probably the market, you may need to update your best forecasting technique, at least the parameters, every 6 months to a year. There are different demand patterns, especially in terms of time series forecast, which we will discuss later. The first one is a random demand around a number, basically. In this case, it seems around 200 we have fluctuating demand, but it is really on the close to that 200 number. So another pattern is again random demand with some trend. In this case, it's an increasing trend. Random demand again with some seasonality and increasing trend. And this is the lumpy demand pattern, which is the most difficult one to forecast, because you couldn't know if there is going to be demand and then what's going to be the size of that demand, right? And we will discuss later what kind of strategies might be the best for a demand pattern like this. In the next couple of slides, we will discuss various forecasting methods, but remember, this is not a complete list of forecasting methods out there. We broadly define forecasting methods under two categories. One of them is the qualitative method, which is based on human judgment, opinions, and subjective, and it is a subjective method. And the other one is a quantitative method, which is based on mathematics, and therefore quantitative in nature. Right? Each one of them has some strengths and weaknesses. Qualitative methods are usually very quick to incorporate latest changes in the environment. Perhaps you just learned that Congress is going to pass a new law, and then you will basically act on it immediately. On the other hand, all the quantitative models are objective and able to consider much information and data at one point. They kind of require some data in order to catch for the changes in the law. For example, first there needs to be the law, and then increase sales numbers, and once the data is established for those sales numbers, then quantitative methods can basically pick up the pattern, right? The qualitative methods have a bias problem, because you are dealing with the people. They may have different biases, different priorities and preferences, and that may reflect on the forecasting accuracy. There are a few qualitative methods I've listed here. Again, remember, this is not the entire list of qualitative methods. The first one is the executive opinion. In this case, you basically bring a couple of or more managers and executives together to come up with a forecast. This is usually good for strategic planning and new product forecasting. The problem you may face is that one person basically can dominate the forecast, especially high-level executives. When they talk first, that may basically be repeated by the others in the group. Then we have the market research. In this case, basically you prepare surveys and understand what the customer wants. The problem with this one is sometimes developing a good questionnaire may be very difficult. And then we have Delphi method. This time this is similar to executive opinion, but it is different in a sense that we bring these experts together and they kind of share their ideas with each other, and they update their forecast. And whenever they have a consensus, basically that is the end of the forecasting procedures. For example, it may work like this. There might be different experts in different topics. One of them could be an economist, another one could be a technical expert, and another one could be like product expert. And you basically ask each one of them what would be the impact of this new law coming up. And they will basically state their perception and ideas. Then each one of them shares with the other one. And finally, when 3 of these experts learn what is out there altogether, they may come up with the final forecast. And the problem with this one is usually you want to keep these experts unidentified to each other. And that means basically you get these things in writing and then share with the other one. The other person will think about what's going on and then make a decision, which is basically a time-consuming process. In terms of quantitative methods, we have time series models and associative models. In the time series model, we assume, or basically it is assumed that the time series of data has the information we need to forecast the future. Right? And that is basically based on the assumption that future will follow the same pattern as the past. Of course, when we do this assumption, we are also assuming that data is basically some kind of historic pattern plus some random variation. So we are going to try to identify that historic pattern. In the causal models, the idea is to exploring the cause and effect relationship and then using this relationship to come up with the forecast. For example, you can look into a market and see how many new houses are built, and based on that you can basically forecast the appliance sales. After going through the process, let's say we identified a couple of forecasting methods that basically fits our needs. The next step is basically applying these forecasting methods, especially in terms of time series analysis to the past data and see how they perform. We use different metrics to decide which forecasting method is the best one, and some of them are listed here. You may find some others as well. First one is the mean absolute deviation, or MAD. Basically, AT is the actual demand at period T and FT is the forecast for period T. So you look at the difference between actual and forecasted using the earlier data and forecasting the earlier time periods, and use that one as a metric. The second one is the standard error of forecast. SF, this is basically the standard error calculation, and it squares the error and then divides by n-1 for the level only. Level is a kind of a straight figure or straight demand pattern with some randomness around that straight line. We also studied what would happen if there is a trend, and when there is a level, trend, and seasonal models. Depending on those, you can update the n-x number based on that 2-3 numbers. Another metric is the mean square error, MSE. This is very similar to MAD, but it is different in a sense that it basically penalizes extreme deviations more heavily. And final one is the mean absolute percent error. Now, when we talk about the MAD or MSE values, or SF in that manner, we will get a number, but that is based on the product. Let's say you are talking to your boss or manager and you said your mean absolute deviation is 500. So that may not hit the manager as quickly as possible because they may not know what is the regular sales numbers for it. Is that 500 out of 5,000 units a month, or 100,000 units a month, right? Or 1,000 units of a month. So if it is out of 1,000 and your error is 500, then it's like a 50% error. That's a big thing, right? But if you are selling on average 1,000 or 100,000 unit and your error is MAD value is only 500, that's a pretty darn good forecast, right? So, and that similar issue exists with the others too as well. So mean absolute percent error basically kind of attack to this issue and says, okay, instead of defining these as numbers, let's look into the percentages. Now, you can go and talk to your manager and say that your mean absolute percentage error for this product is 3%, for another product is 10%, and you also have 50% error, right? So it is kind of easy to bring all the products to the same level and be able to evaluate their forecasting accuracy all together. Another metric we use for the forecasting accuracy or forecasting evaluation is this bias. Basically, you just subtract AT minus FTs and divide by N. What it means is if this is 0, overall you are just okay. Sometimes you are overestimating, sometimes you are underestimating, but you are not basically biased either way. If this is a positive number, let's say 50, that means on average you are overestimating by 50, right? If it is minus 50, that means you are on average you are underestimating by 50. This is kind of a good information, because if you know that overall you are overestimating by 50, then you could basically adjust your forecast. Next time when you see 215, you may say, you know, on average I'm underestimating, so let me kind of bump this number a little further. Forecasting is always wrong. So that means that whatever the number you come up with at the end of all these adjustments, including considering the bias and so forth, it is highly likely that your exact number is not going to be the right number. So for that purpose, we actually prefer having a range of forecasts rather than a single number. What it means is that with certain confidence, I can tell you that the next month's sales are going to be between 180 and 220, right? As that range gets tighter and tighter for the same probability, then you are basically forecasting at a higher accuracy, right? So idea is always get a range rather than a single number. And for example, let's say I get this 180 and 220. If the manager is optimistic about the forecast or the future, then he or she may plan based on 220 number. If the person is pessimistic about the future, and then they may say, okay, I'm gonna go to 180 or somewhere in between, right? So having a range is really important for the forecasting. Sometimes products have highly uncertain demand. For example, that lumpy demand we discussed earlier. For those type of products, we try to basically use certain tools to improve our forecasting accuracy. First, delay forecasting as long as possible. Short-term forecasts are more accurate than a long-term forecast, and we live that one in our daily life. When you go to weather.com and check tomorrow's weather, it is gonna be probably very accurate in terms of predicting the weather, right? Then you can also check the weather for the next 10 days. And you can take a snapshot of that 10 days. And then as you go through those days, you may see that some of those days, actually future dates, are adjusted in terms of forecasting. Because as we get closer to that future time, our forecasting accuracy increased. Perhaps 3 days from now, there was a rain in the forecast, but when we live 2 more days, we can see that that rain is not actually happening the following day, but 2 days after that, right? So delaying forecasting as long as possible is really important. Unless it is necessary to forecast next year's demand from now, you shouldn't forecast. Next, prioritizing supply by product's degree of uncertainty. Let's say you are buying and selling certain number of products. Some of those products may have a steady demand, and you should buy them as soon as possible perhaps. But then there will be some items that you are not sure what's going to be the real demand. Again, we just go back to delaying the forecasting, delay forecasting as much as possible for those uncertain products. Next one is applying the principle of postponement. For example, you may hear from your salesperson that this new customer or one of the existing customers has a big plan to expand this product line, and they are going to increase their purchase by 10 times. It shouldn't basically go to your forecast or production plan immediately, right? Until you sign the contract, please do not commit anything, right? Because the things can change and you cannot just always play by ears to make an official forecast. The next one is creating a flexible supply to changing demand. So you should be having enough additional capacity to change, basically increase or decrease your production amount or supply or warehouse processing capabilities, right? And those flexibility helps you when you have uncertain demand. And all the demands are usually uncertain, but when it is very highly uncertain. And finally, you need to be able to respond quickly. Again, this is when you don't have any other ways to deal with certain situations. Let's say a rig down situation, you have to basically bring this product, perhaps expediting the shipments and so forth, rather than trying to plan everything in advance. Another tool that can be used for highly uncertain demand is this concept called collaborative forecasting. In this idea, basically multiple entities in a supply chain comes together and they share the information and hope to improve the forecast accuracy, right? For example, Walmart and Procter & Gamble does this one. The idea is that Walmart basically share their actual sales data with Procter & Gamble, and then they together make forecasts, and that helps them to basically improve the forecasting accuracy. And you can think similar situation in an industrial distribution environment. Let's say you have a manufacturer line and you are planning to increase this line by 20% next year without talking to your manufacturer, and then realizing that they are actually planning to discontinue this product, right? Or another example could be, and the manufacturer is also planning a big promotion on these products and you are not aware of it. So talking to other parties in supply chain basically helps you to reduce the forecasting error. To summarize, when you have a highly uncertain environment and you think forecasting is not even appropriate, seeking information directly from customers. They may have forecasts and they may be able to share with you, so you can plan according to those forecast results. Collaborate with the other channel members, as we just discussed in the collaborative forecasting. Apply forecasting methods with some caution. Know that these numbers is ballpark there, but it is not really reliable. Again, delay supply response until the demand becomes clear. Shift the demand to other periods for better supply response. Especially when there is a supply shortage, you may kind of encourage your customers to shift demand. One way is providing incentives or making them aware that there might be an incentive for the next month when you are out of stock this month, right? And finally, develop quick response and flexible supply system. Again, you are not able to forecast, and we don't like building a lot of inventory. So rather than building a lot of inventory, we would rather have a capability to supply the product quickly. Overall, forecasts are uncertain, imprecise, and unavoidable. Long-term forecasts are less accurate than the short-term forecast. Think about the weather forecast. Aggregate forecasts are more accurate than disaggregate forecasts. So basically, when a company perhaps making a forecast for budgeting, let's say, and they say they are going to generate $5 million revenue in this product line, and they go for specific items under that product line, their product line forecast is more accurate than specific item forecasts. Forecasts are made for many purposes using many methods. As we discussed, you need to go through those methods and choose which one is the best method for your situation.